So far, in this Deep Learning Foundation series, we have built the core idea that deep learning mainly works because neural networks can stack layers upon layers and learn rich representations of the data. Early layers learn simple patterns. Later layers combine them into high-level features, and that's exactly why deep neural networks became so powerful in computer vision, language, and everything we see today. But see, this depth comes with a real training challenge. When a neural network gets very deep, the model may look fine on the paper, but training is a big challenge. Learning can slow down dramatically and may not train altogether. The loss barely improves, and these early layers, the ones that should be learning the most foundational features, stop updating meaningfully. This is one of the classic bottlenecks in deep learning, and it has a name. It's called vanishing gradients, and the topic of today's video. Let's jump in. So what exactly vanishing gradients is? Again, in the deep learning, right, the goal is to have deeper and deeper neural networks, where each layer can learn different types of features in the training data we are using. So, but the problem with this deep neural networks is this vanishing gradients. So why that happens? Okay, to understand that, let's look at this VGG16 architecture, the pre-trained VGG16 model, right? We have leveraged this in one of the previous videos. So let's look at this VGG16 architecture. So this is how the architecture looks like. We have already seen this in the previous projects, but basically the VGG16 architecture, it's like a pyramid. So most of this large pre-trained model follow some kind of pyramid structure. So what do we mean by pyramid? When I say pyramid, if you see, the earlier layers are more larger, in terms of spatial features, right? The height and width are larger, the depth is smaller. As you go downstream in the network, right, the spatial features, the height and width reduce, but the depth increases. Meaning, again, if you see the filter size, right? Initially it was 64 filters, 128, 256, 512, and so on. So this is the pyramid structure which many different pre-trained models follow in some kind of a hierarchical structure. And these deeper hierarchies are good because they let you learn and reuse many features. In principle, a deep stack of narrow layers like what you see here perform way better than a shallow stack of large layers. Okay, so that's what, typically, when people have trained this, many pre-trained models in computer vision, this is the kind of structure they use, right? Deep neural networks, right? A shallow stack of, a narrow layers with a deep stack. But see, there's a problem. There's a problem with these deep networks, and that's called vanishing gradients. What it means is the back propagation stops working as you have too many layers chained on top of each other. And basically the model won't train. So why this is happening? So again, if you see why this is happening, at the end of the day, the deep neural network is what? It's different layers chained on top of each other, right? For example, like this final layer, right? This is chained on top of all the subsequent earlier layers. So again, if you think of some kind, at the end of the day, we're trying to predict the Ypred, right? The final, the classes, let's say, for the image classification. So the Ypred is nothing but it's a function of, let's say if it's function of Fi is a function of F4 is a function of F3 is a function of F2 is a function of F1, and F1 is a function of X. I mean, just to illustrate the point here. Bottom line, what I'm saying is each layer is chained to its previous layer. It's built on top of the previous layer. So with this kind of a chaining or stacking, what's happening is that it becomes very, very difficult for the error information. Let's say the final loss function is the error between Ypred and the actual Y. So the gradients of this error information, it becomes very difficult for this error information to propagate throughout the network when you have very deep chain of neural networks. Why is that? Well, that happens because each of this layer in this network introduces some noise. As you chain or stack many layers on top of each other, the noise coming from each layer, right, it aggregates and it overwhelms the gradient information, with the result that the back propagation simply stops working and the model won't train. So that is the problem with vanishing gradients, right? When you have deep neural networks, you have vanishing gradients. Your model won't train. But again, our goal is to have deeper and deeper neural networks because, they can in principle fit any types of data by learning complex patterns in the data. Vanishing gradients are a fundamental challenge in deep learning. Not because depth is bad, but because training deep neural networks can be hard. When many layers are chained together, gradients have to travel backward through all these layers during backpropagation. And because of repeated multiplication, these gradients can either shrink layer by layer, essentially vanishing, which is vanishing gradients, or they can grow exponentially, leading to exploding gradients. In this video, we focused on vanishing gradients problem because it's more common in deep architectures, and the way to fix this problem is through techniques like residual connections and batch normalization, which we'll cover in the next video. So please stay tuned and happy learning.